Welcome back, everybody. So this week we're going to be dealing with making physical circuits, and to do that we're going to start with a circuit on a breadboard. I've laid out the schematic for what's happening on the left, and let's just quickly talk about it. I'm running 5 volts and ground over to the main rails of the breadboard. I've got a small series circuit with an LED and a 220 ohm resistor, which is this part of the schematic. The long leg of the LED is connected back to pin 9 on the Arduino with this green wire. And the other part of this circuit, pictured at the top of the schematic, is a voltage divider with a light-dependent resistor and a 2 kilo ohm resistor. 2 kilo ohm connecting to the ground, the light-dependent connecting to positive 5 volts, and where they connect, in this row, we have a white jumper going back to pin analog 0. So this little circuit is real simple. It just makes this light blink dependent upon how much ambient light is around. So with a flashlight I can get it to start to slow down more and more, or speed up as I deprive it of light. Its activity you can change in the code, and let's go take a look at it real quick, and then we'll come back and start to make this physical. So here's our code for physical circuits. We've got a few integers declared at the top, our analog in pin being A0, our red LED pin, 2 integers for the sensor value, one for the initial reading and one for the mapped value, and 2 different thresholds. And these thresholds, these you can start to change depending upon your ambient light situation, how you want it to work out. Those are completely up to you. And our setup, we're just declaring our red and output, our analog in and input, and doing some serial communication so that we can look at the numbers. If we need to start tweaking our values, that's where it's really helpful to have the serial communication. So in our loop, we're doing a bare analog read of the pin for our first sensor. Sensor 2 becomes a mapped version of sensor, which will be reading between 0 and 1028, and we're mapping it to between 0 and 300 so that we can tighten it up, keep it within a range that's a little bit more amicable to work with. We're going to be serial printing the threshold and the sensor value after it's been mapped, just so we can take a look. And we just have a few if statements that give it a few different blinking states, longer or slower blinks. So that's it. That's simple. Load that up and we'll start building the circuit. So this first method of constructing physical circuits is a little bit more tentative than the second. It's something you can deconstruct a little bit easier, and you need much less in the way of equipment to do so. I've gathered up duplicates of all our components from the circuit, as well as gathered a glue gun and a pair of pliers. We've got our schematic here, and I'm going to just get everything set up a little bit closer so we can see what's happening. So, here we go. So we've got our components, our glue gun, and I'm doing this on a piece of plexiglass. You could do it on paper or anything you don't really care about, just something that won't stick to permanently, the hot glue, just a working surface. So we're going to take a look at the schematic and see what it tells us. If we look at the 5 volts and the ground, we can see there's a few things that connect to them directly. And I like to work there inwards when I'm kind of conceptualizing and constructing things. If we start at the 5 volts, that's the easiest. That's just got the light-dependent resistor attached to it. In our previous circuit, the 5 volt was hooked up to the red wire. So what we can do at this point is take our red wire, our light-dependent resistor, twist them together, and just like lay them down on your work surface, and now hit it with some hot glue. Nothing fancy. We're just gonna use the hot glue as a little bit of a binder. We'll also start to hold our little circuit in place while we work on it. A little bit of a blow can help cool that off sooner than later. We also know from the schematic that the 2K resistor connects back to ground as well as the 220 ohm resistor. Sorry, just gotta keep blowing this, make sure it hardens up. Great. So what we could do in this instance is take both of these components and attach them to our ground wire directly. So just gonna grab all three of our components and twist the legs together. Nothing too fancy. Start with one resistor, and then I'll just do the second one. This is where it's handy to have long legs on your components for something like this. Great. Now that we've got those little guys attached, let's see if I can get them on camera. Yeah. Got those attached. Let's lay them down and get some hot glue on there. Nothing too fancy. I'll blow a little bit of time and air across them. Inevitably, we'll be attaching this leg of the light-dependent resistor to this leg of the 2K resistor, as well as the end of our white jumper cable to go back to the Arduino analog pin. We're also going to be attaching the short leg of our red LED to the other end of this resistor once we've given the hot glue a little bit of time to kick. And then the long leg will be attached to the green wire back to digital pin 9 on the Arduino board. So add a little bit of time. Great. And they're wonderfully flexible. And now we can just start to attach them in space. Handy twist. So here's where our voltage divider is gonna live. Twisting these guys together, and they'll want to be attached to this white jumper to get back to the Arduino board. And we'll make this happen somehow. There we go. Oops. The next process, soldering, is much more firm, much more stable, much more long-term, but this will help prototype objects, and these can last. There we go. Just physical contact, metal to metal, and cover it in hot glue. There we go. And then we grab our short leg, or if you've cut them, the flat side of the top, the cap, the little brim, there's a flat on the short leg. We can connect that to our resistor, little hot glue, and then we'll use a jumper wire back to the Arduino. There we go. And we could just look at the schematic. The long leg of the LED goes back to pin 9. That's our green wire. So once this sets up a little bit, we'll attach the green wire to this end of the LED, plug all these components back into where they were on the Arduino, and pop them off of the plexiglass. So we have it out in space. We can hide it inside somewhere. Becomes much more compact. But hot glue takes time. Okay. And just the last leg. And a little hot glue. Really get it nice and covered there. This way the hot glue takes all the stress and not the metal connection. If you feel like any of your connections need a little bit more support, you can go back in with more hot glue. You know, a little dab here, a little dab there. Keep them all together. Make sure everything sets up before you let it take any stress. Might even give a little dab here. There we go. Alright. We'll let this kick up. We'll take it off the plate and plug it back in. So here's our hot glue circuit peeled up off the plexiglass. We can check it with a flashlight, make sure that our analog read is working. Awesome. And you can start to see here how the physical circuit relates to the schematic of the circuit in a sense. We can see our voltage divider, our light dependent resistor, our 2K resistor, hot, ground, and the analog 0 read, as well as our line from pin 9 back to ground through a 220 ohm resistor. So these hot glued joints will take the stress off of the metal connections. They're also insulating these metal connections, and you do want to make sure that if you're going to be putting this into something, you don't start to cross your connections by touching them together. Don't short them out. If you want to, you can take this as it is now and start to lay hot glue down these to insulate them, or just electrical tape or anything to keep them from touching each other, crossing over, and shorting out your circuit. Alright, pretty fun. It's also very forgiving. I'm going to actually be ripping this all apart to do the soldering demonstration. If something on this particular circuit doesn't work for you, start jiggling connections, start pinching connections to make sure they're all tight, all connected. If one of them doesn't seem like it's connected or working, just rip it apart. Do it again. Make sure you use your pliers so that it's a nice tight connection, and it should work pretty well. These lines can be as long or as short as you want. You can go by wire, strip it back to make your connections, make these very long, very lanky. Hide your Arduino in the base of a piece whilst all your electronics are up at the top. Lots of options once these connections can start to get extended. Now let's see what we can do with a little bit of higher technology connections with soldering. So here's the basics of what you'll need to solder your circuits together. An iron, rosin core solder, rosin core electrical solder. There's lots of different kinds of solder, but we need rosin core solder. It's going to have a silver base. They used to make it in lead, sometimes they still do, but a silver rosin core solder is perfect. Your iron, and I'll leave a link in the description to a variety of different irons you can choose from, little starter kits. Also very handy is a pair of electrician's pliers, mostly for these little holes. These let us take wire and strip the insulation off them relatively easily. They're sized for different gauges of wire. This is a piece of 22 gauge solid core wire. Just grip it about 1/4 of an inch down, pull, and it pulls the insulation right off. So this is handy to have, especially if you're going to be lengthening your circuits or making additions to your circuits or inventing your own circuits that are larger than just the components that you have on hand. This here is stranded wire. You can see it's actually made up of a bunch of little strands, versus this first piece I cut, which is a solid core wire. I prefer solid core for this type of project, 22 gauge, because it fits really neatly inside of an Arduino slots. And now that our soldering iron is hot, what I'm going to do is just do a test solder on this. Give them a twist together. basics of soldering are that you need it to be hot and you need it to be clean for the connection to hold. So we twist them together nice and tight, and we're ready to start soldering. So now that our wire is twisted together, I'm just holding it up in the air so you can see and in place with a pair of helping hands. You can get these on Amazon from your local electronics store. They're great to have around. My iron is hot, and the sponge, this is just a dish sponge I cut to fit in there because I've lost the original one. It's moist so that I can clean my tip, get any excess solder, burnt resin off of that tip to make it nice and shiny. This joint needs to be hot and it needs to be clean. The cleanliness comes from the rosin core of the solder. That will flow with the metal once it's heated. I like to tin my tip a little bit by just touching a little bit of it to the surface. That'll let it flow onto our hot joint. Don't want to over solder it too much. What doesn't stick there will stick to your iron and just get wasted when you clean it off. A little bit of a blow. That guy's nice and strong. So let's take this process to our circuit. So here's the same circuit from before, same components, the same wires. I've just ripped them out of the hot glue and rewrapped them around each other. Our voltage divider between 5 volts and ground with the analog 0 line in between. And then our series circuit going from ground back to pin 9 through a 220 ohm resistor and our LED. So at this juncture, I'm just holding them down. I've got them wrapped nice and tight. I'm holding them down with just a pair of pliers or whatever you got around that's heavy. I'm going to clean the tip of my soldering iron. Just tin it a little bit with a little bit of that solder. Don't breathe the fumes in. Use this somewhere ventilated. I'm just going to lay it to the material and add my solder. It'll flow onto hot, clean metal. And there we have it. Nice and easy. Hot, clean metal. Just let it get a little hot and you're good. All of these components are relatively durable. You don't have to worry too much about overheating them, but the quicker you can make this process happen, the better. Less heat is drawn into the components, and that's it. Just clean the tip when you're done, and let's plug this one into the Arduino and see what happens. So here's our soldered circuit, our voltage divider between hot and ground, analog 0 and pin 9. Check it with the flashlight to make sure the light responds. Perfect. Yep, working just fine. Much more durable than the hot glue, but a lot more permanent. So I like to start with hot glue circuits to work everything out, figure things out, and then start to move forward into soldered circuits, things that could become more structural, more durable, and more permanent in your work. Now I've gathered all the components I need to make this circuit one more time, except we're going to add a new piece into the mix, this piece of perforated board. Again, you can get it on Amazon. I'll put a link in the description. You can get it at electronics stores, what have you. It's a board that's perforated with holes. One side has copper pads on them that you can solder to, and excuse me. And we're going to use this to lay out our circuit in a little bit more of a compact fashion, a little bit more rigid. These guys literally slide right through the holes, nice and easy. I'm going to make sure I'm getting the right side of my LED in the right direction. Just push it right through, just like that. Once you have a component through, you can take your soldering iron, give it a quick clean, and using these copper pads, lay some solder onto it. It's gotta wait for that heat to transfer. There we go. Ideally a little bit less than that. There we go. Now our component's in there. It's not going anywhere. We're locked in, and we can even use these legs, just like with the other types of circuits, to make connections with other components. So I'm just going to drop those all in addition to our jumper wires, and I'll do that off camera to save you guys some time. So now that I've pushed all the components through the perforated holes, just bent over the legs as such to make the connections, I'll go ahead and solder these as where appropriate and cut down the excess with a little pair of snips. After that, we'll put in the jumper wires. So now that the components are in there and soldered, I've only left areas of length where I need to hook up my jumper cables to the breadboard or to the Arduino. And I'm going to keep these the same colors as they've been throughout the rest of the video. So we're just going to slide them through, give them a quick solder. Again, the green goes to pin 9, red goes to one side of the light dependent resistor and back to 5 volts. Black, which is where we're going to connect in between these two resistors, is going to go back to ground, and the white one is going back to analog 0. So I'm just going to give this a flip, give this a solder, and we'll hook it back up to the board. Now that I've got it flipped, I'm just bent the pins over so that they connect to their appropriate points. Now I'm just going to give it another quick solder, haphazardly holding it in place with a pair of snips, praying it doesn't shift on me. Again, do this in a well-ventilated area. And there we go. Now that all these are connected, you can take electrical tape to the back of this to insulate it. You can take hot glue to the back of this to insulate it. We just want to protect these connections from cross-connecting, maybe on a piece of metal surface. If I drop this down on my welding table, I'll make it have a short circuit occur. One of your tools haphazardly, just be careful. Insulate this before you go and implement it into a project. And here's the circuit hooked back up to the Arduino. Just to check it, flashlight, give it a little bit more intensity. That should slow it down. Yep. Speed it up and then some. Excellent. So now at this, you could even trim this down a little bit to make this a little bit more compact. What's kind of interesting is, depending upon the environment, the position of this board now determines how fast that light blinks, with more or less light from the ambient environment. So it could be something that's dependent upon sunlight that changes over time. It could be a particular spot in your room or a gallery that has a particular effect of the light over time. It could be handing your viewers flashlights to play with the work. So there's a lot of different ways to start to make this back and forth between the viewed and the viewer. Have fun.